Use the data booklet to help you answer this question about amino acids. Figure 1 shows parts of 2 polypeptide chains in a beta-pleated sheet of a protein. So remember, a beta-pleated sheet is when the primary structure sort of folds back on itself. So this is kind of like the bit of the primary structure, and this is another bit of the primary structure, and we're folding back on ourselves to make a secondary structure, beta-pleated sheet. It says they're held together by hydrogen bonding. How do those hydrogen bonds form? So this is really an AS question in disguise. How do hydrogen bonds form? So the idea of a hydrogen bond is not just a delta plus attracts a delta minus, but that a lone pair on oxygen is attracted to the delta plus hydrogen, or the delta plus hydrogen more correctly is attracted to the lone pair on oxygen. So the delta plus H, the electron deficient H, is attracted to the lone pair on oxygen in another part of the protein structure. So it's not the same oxygen or nitrogen that the H was attached to. Now what we need to do is go to the data sheet and look up the amino acid cysteine. If we look up cysteine, we see that the R group is a CH2SH. Okay, so here's our cysteine, and it's going to join. When we form that sulfur-sulfur bond between two of these, we're going to lose the hydrogen and join two of these CH2SHs together, but without the hydrogen. The type of bond in question 8.2 between two influences the three-dimensional structure of a protein. So the three-dimensional structure of the protein. So we already were, the second structure which already being held together by hydrogen bonds, and then we're further folding it into this thing held together by many things, including the sulfur-sulfur bridge, called a tertiary structure. Now we have to draw a dipeptide, so that's 2. Alanine, where the R group, if we have a look on our data sheet for that, alanine's R group is a CH3, and serine's R group is a CH2OH. So we're putting these together, so we're drawing a dipeptide, and it's the zwitterion. Okay, so it's an amino acid, but when we make the zwitterion, it becomes an ammonium group. And then we have a C with a H, and then we have our first R group. Now we can do it either way around and both will be marked right. I'm going to put alanine first because it came first in the list. Then it's a carboxylic acid, amino acid from left to right. And then it's a dipeptide, so it's going to join to the next amino group. Then we're going to have the next middle C with its R group. So we've already used alanine, so I'm going to use serine now. And then it's a zwitterion, so the last carboxylic acid is going to become the carboxylate salt. Now you could do this exact same diagram and just swap around these two parts, and you would have the other zwitterion possible.